Today, we will learn about the factor theorem and splitting the middle term related to polynomials. In the previous video, we learned about the remainder theorem, which states that when a polynomial p of x with power 1 or more than 1 is divided by a linear polynomial x minus a gives a remainder p of a. And taking this theorem one step further, the factor theorem states that if p of a gives the remainder 0, that is, if x minus a divides p of x completely, then x minus a is a factor of p of x. And if x minus a is a factor of p of x, then p of a will be 0. Let's see an example related to this theorem. Check whether x plus 3 is a factor of the polynomial 2x squared plus 7x plus 3 or not. According to the factor theorem, if x plus 3 is a factor of the polynomial 2x squared plus 7x plus 3, then p of minus 3 should be 0, where minus 3 is obtained by equating x plus 3 to 0. That is, if we write the polynomial this way, we have to check whether p of minus 3 is 0 or not. So let's check it. Now we can say that, according to the factor theorem, x plus 3 is a factor of this polynomial. Friends, can there be more factors of this polynomial? Yes. The number of factors of a polynomial depends on the highest power of the variable of the polynomial. For example, a quadratic polynomial has 2 linear factors and a cubic polynomial has 3 factors, etc. So now, let's learn how to find all the factors of a polynomial. For this, we have 2 methods. One is factor theorem and the second is splitting the middle term. Suppose we are given a quadratic polynomial 2x squared plus 7x plus 3. From this, we will derive the factors using the factorization method and splitting the middle term method. First, let's see the factorization method. The polynomial is 2x squared plus 7x plus 3. To solve using this method, the coefficient of x squared has to be 1. So we can take 2 common out of it and write it like this: 2 of x squared plus 7 by 2x plus 3 by 2. Now, if we write x squared plus 7 by 2x plus 3 by 2 equal to p of x, then this will become 2p of x. And suppose if a and b are its 2 zeros, then you can write this polynomial in terms of factors as 2p of x is equal to 2 of x minus a of x minus b. And here, you can see that the constant is ab. That is, for this polynomial, ab is 3 by 2. So we will find 2 numbers a and b whose product is 3 by 2. First of all, plus or minus 1 and the number itself, that is plus or minus 3 by 2 are the factors. Also, 3 by 2 can be written as 3 multiplied by 1 by 2, that is, plus or minus 3 and plus or minus 1 by 2 will also be factors. Thus, some possible values of a and b can be plus or minus 1, plus or minus 1 by 2, plus or minus 3, plus or minus 3 by 2. Now, substituting all these values in the polynomial, we have to find which of these will make the value of the polynomial 0. P of minus 1 by 2 will be 0 and P of minus 3 will be 0. We get the values of a and b. Now, we can write them in terms of factors of polynomials as x plus 1 by 2 and x plus 3. And finally, we get only 2 factors of this polynomial as it is a quadratic polynomial. Now, let's solve this polynomial using the method of splitting the middle term and see if the results are the same or not. Friends, we have learnt this method in the context of quadratic equations in our previous session. As you all know, here we will multiply the coefficient of x square, that is 2, and the constant 3 to get 6. And then find two such numbers whose product is 6 and sum is the coefficient of the middle term, that is 7. The numbers whose product is 6 and sum is 7 are 6 and 1. Now we will split the middle term and write it like this. So here we can see that in both the situations we get the same factors. You can check whether the polynomials is being reduced to 0 by finding the value of x from both the factors. Friends, that's all in this video. So what did we learn in today's video? Factor theorem and splitting the middle term. Now let's meet in the next video where we will solve some questions based on polynomials. In this video, we will learn to find the factors of polynomials using the factor theorem and the method of splitting the middle term. So let's start with the first question. Check whether x minus 2 is a factor of the given polynomials. According to the factor theorem, if x minus 2 is a factor of these two polynomials, then p of 2 should be 0, where 2 is obtained by equating x minus 2 to 0. That is, if we write both these polynomials this way, we have to check whether p of 2 and q of 2 are 0 or not. So let's check. In both the polynomials, x has to be replaced by 2. And now we get p of 2 is equal to 0 and q of 2 is equal to 12. Now, according to the factor theorem, we can say that x minus 2 is a factor of the first polynomial, but not a factor of the second polynomial. So, let's move on to the next question. Find the factors of the given polynomial. So friends, tell me, which method will you use here? Can we start with the method of splitting the middle term? Friends, this is a cubic polynomial and we use the method of splitting the middle term in the case of a quadratic polynomial. Therefore, we will solve this polynomial using the factorization method. The first step is to make the coefficient of x cube 1 and find the factors of the constant term. Here, the coefficient of x cube is 1, which means we have to find the factors of minus 50. And this is quite easy. We just have to make a list of those numbers with which minus 50 is completely divisible and some of those possible values can be. And now we come to the second step. One by one, we will substitute these numbers along with their signs in the polynomial and observe which number can make the value of the polynomial 0. So p of 1 becomes 0. P of minus 1 becomes minus 72. P of 2 becomes 84. P of minus 2 equals minus 72. P of 5, 600. P of minus 5, 0. P of 10, 2700. And P of minus 10 is equal to 0. Here, for the cubic power of x, we get 3 zeros. And since this is a cubic polynomial, there will not be any more zeros. And now, we can represent this polynomial in terms of its factors. P of x is equal to x minus 1, x plus 5, x plus 10. Friends, after finding the first factor, you can solve it without finding the other factors. Let's see how. When we got p of 1 as 0, we derived our first factor x minus 1. So, now let's take x minus 1 common from this cubic polynomial. If this polynomial had minus x square after the first term, then after taking out the common x square, we will be able to write like this. But here, instead of minus x square, we have 14x square. So now what? we will subtract and add x square once from x cube. Now, we can take it common. If you take x square common from the first two terms, you will get x square of x minus 1. The remaining x square plus 14x square will become 15x square plus 35x minus 50. Now we can perform the same with 15x square. Here, if the first term was minus 15x, then by taking 15x common, we could write like this 15x of x minus 1. So let's subtract and add 15x once. Now, again 15x and 35x will get added up to become 50x. Now, taking 50 common, we can write x minus 1. After this, by taking x minus 1 common from all the terms, we can express it like this, x minus 1, x square plus 15x plus 50. This is in the form of a quadratic polynomial. Can we now solve it using the method of splitting the middle term? Yes. Here, the coefficient of x square is 1 and the coefficient of the constant term is 50, and the two terms whose product is 50 and the sum is the coefficient of the middle term, that is 15, are 10 and 5. Pause the video and solve it yourself and see if the other two factors that you are getting are the same or not. Friends, that's all in this video. What did we learn in today's session? To find the factors of polynomials using factor theorem and the method of splitting the middle term. In this video, we will solve some interesting questions using factor theorem and splitting the middle term. So let's start. If x is one of the factors of the cubic polynomial p of x is equal to x cube minus 2x squared plus 4x, then what can be one of the zeros of this polynomial? Friends, the answer to this question lies in the question itself. We do not even need to solve it completely. You can pause the video and think about the answer. Here, we can also say that the factor of this polynomial is either x or x minus 0, all the same. So, according to the factor theorem, 0 will be one of its zeros. You can also check the value of p of 0 whether it is 0 or not. Now, let's take the next question. Solve the given polynomial using the method of splitting the middle term. Friends, there is no middle term here. Can we write it like this? X square plus 0x minus 4. Yes. The coefficient of the middle term is 0 and the constant is minus 4. That is, we need two such numbers whose product is minus 4 and the sum is 0. Friends, can those two numbers be plus 2 and minus 2? Yes. The solution to this question will be somewhat like this. And with this, let's end this video. In this video, we learned to solve some interesting questions related to the use of factor theorem and the method of splitting the middle term.